All right, so 4.2, logarithmic functions. So we have y is equal to log base b of x. And I can write that a little bit better. Where my pen go? So it's log base b of x. And the exponential way of writing that is b to the y power equal to x. So both of these equate out to give you the same relationship. So notice b is always going to be your base. Either it's the base of your log or it's the base of your exponent. And the way I look at it is that what is next to b during my log relationship is not next to b during my exponential relationship. All right, so you see log base b of x, and then here I have b to the y power is equal to x. And then in red, I was just writing what log base b of x is. That's the logarithmic function with the base b. Also notice the details. X is positive, your base b is positive, and of course your base is not equal to 1. And you'll see why when we get into the properties. All right. And so here I was just re-emphasizing the log form versus the exponential form, and how your base is always going to be the base, whether it's the base of your exponent versus the base of your log. Y would be your exponent. All right. I already got these up here, but look at them. So when you look at 2 log base 5 of x, I always say start with the base first. So you write the base. If you want to turn this 2 equal to log base 5 of x, you write your base first, which is your 5. Once again, what is next to your 5? What is next to your base in the log form should not be your exponent when you go to your exponential form. It should be the other number, which is 2. So that's why you have 5 squared is equal to x. Once again, this number over here by itself is the exponent. Same thing with this log base 3 of 7 is equal to y. 3 is my base, so you write that first. Then what would be the exponent is the number on the other side of your equal sign, which is y, and that's equal to 7. And then 3 equal to log base a of 64. Same type of deal. A is your base, 3 would be your exponent, and then 64 is the other number on the other side. Any questions? All right, so talking about writing it in log form, they give you the exponential form. They want you to take it back to log form. So same thought process. Your base, I have 12 squared equal to x, I would start off with log base of 12 because your base is going to be your base regardless. So that's log base 12. And then once again, what is next to the 12 in this relationship is not going to be next to the 12 here. So that's log base 12 of x is equal to 2. All right, same thing with b cubed equal to 8. Your base is b. And then it's going to be log base b of 8 equal to 3. Once again, recognizing what's next to b in my exponential form should not be next to b in my logarithmic form. And then e to the y equal to 9. It's going to be log base e of 9 equal to y. Any questions? All right, so we have our 4 general properties of your logarithms. Log base b of 1 is equal to 0. So that's in general. Log of 1, period, no matter what the base is going to be equal to 0. 2 and 3 roots or properties 2 and 3 are very similar. Log base b of b is equal to 1. So in other words, if you just had log base b of b, that would be equal to 1. But the reason being is because the exponent is 1, and you'll be left with just the exponent. So if you had log base b of x, basically it simplifies. This cancels out, for lack of a better way of expressing it. Log base b of b to the x power would leave you with just x, whatever the exponent was. All right. So that's the same thing that happens here. You just left with the exponent. Similarly, if you have b raised to the log base b of x power, so in other words, this whole thing is an exponent, the b in the log base b will cancel and leave you with just the x. All right. So over here on the right, just put some numbers on it. Log base 5 of 1 is 0. Log with any base applied to 1 would be 0. Log base 7 of 7 simplifies to 1. Log base 4 of 4 to the 5th power simplifies to just 5. And then 8 to the log base 8 of 9 is going to simplify to just 9. All right. Now we have 2 types of logs that will always be in your calculator, your scientific calculator. It's common log. That's the log base 10. When you don't see anything there, as far as your base is concerned, they will always assume that there's a 10 there. And they will assume you know that it's a 10 there. So if it's log base 2, you have to write that too. But if it's log base 10, you do not have to write anything there. When you don't write anything there, it is always assumed there's a 10 there. That's why it's called the common log. So the properties for the common log hold true. Log Common log of 1, or log of 1 is equal to 0. Log of 10 is 1, because remember your base down here is 10. Log of 10 to the x is x, and then 10 log to the log of x power is going to just be x. So your properties hold true, it's just based on 10. All right. Then we have the natural log. It's log base e, your exponential function. It's your exponential function. And that's in your scientific calculator as well. But it's log base e of x. And so that's expressed by ln of x. Some people say ln. All right. So your natural log properties, all of them hold true as well. It's just that that's based on e instead of 10. Any questions? All right. So, let's say if you presented with log of 100 and they ask you to simplify, then you would break down the 10. Oh, didn't mean to write that. So you break down the 10 break down the 100 into 10 squared. That's 10 times 10. And the reason why you do that is because the base is 10. And so that piece right there, will cancel out for us, leaving us with just the exponent of 2. All right. Same thing happens in this one. We have 10 raised to the log of 33. So this 10 and the log will cancel, leaving us with just 33. All right. Next one, we have the natural log of 1 over e to the 6. So first thing I did was I rewrote 1 over e to the 6 as e to the negative 6 power. Remember to write it without it being a fraction. You can bring your exponent up top, but turn it negative. And then this part right here will cancel for you, leaving you with just negative 6. E to the natural log of 75. E to the natural log will cancel, leave you with just 75. All right, so this one, log base 3 of log base 7 of 7. So this log base 3 is being applied to the log base 7 of 7. So first thing we do is we recognize that we can simplify what's inside of the parentheses. That will give us just 1. Log base 7 of 7 is 1. And then any log of 1 is going to be equal to 0. So that simplifies to just 0. All right. So the next one, log base 5 of log base 2 of 32. So since we have this base 2 here, we can break up the 32 in terms of 2. You always want to do that if possible. You compare the base to the number that you have, and you break it up according to that number. So I rewrite that 32 as 2 to the 5th power. So that log base 2 of 2 to the 5th power will simplify to 5. Then the log base 5 of 5 is equal to 1. All right. Questions on that before we look at 4.3? All right. Properties of logarithms. So we have our product rule, log base b of m times n. You can rewrite that. Log base m plus log base n. Log base b of m plus log base b of n. Then if looking at the quotient rule, log base b of m over n will be log base b of m minus log base b of n. And then the power rule, if you have log base b of m to the r power, you can bring the r down front, and that'll be r log base b of m. All right. Questions before we put this in motion? All right. So they may ask us to expand an expression. So if I have log base 4 of 35, I can break up that 35 into 7 times 5. And then that 7 times 5 lets me break it up into log base 4 of 7 plus log base 4 of 5. All right, do the same thing here. We have log base 10 of 10x. So don't forget that log, when you don't see anything there, they assume you know there's a 10 there. So we can break it up into log of 10 plus log of x. And then log of 10 will simplify to 1. So that's 1 plus log of x. Next one, log base 7 of 19 over x. That's division, so we can break it up using subtraction. So it's log base 7 of 19 minus log base 7 of x. So there's nothing we can reduce with that. Next one, natural log of e to the third power over 7. Once again, it's division, so we can separate our terms by using subtraction. So it's log or natural log of e to the third power minus natural log of 7. So ln is the natural log. And natural log of e to the third power simplifies to just 3. And natural log of 7 cannot be reduced, so they'll just stay right there. All right, and here, looking at the power rule, log base 5 of 7 to the 4th power. So we can bring the 4 down front, and that's 4 log base 5 of 7. And then F, same thing happens here. We recognize though, oh, still have my eraser on, that this square root is the same thing as 1/2 as an exponent. So I just rewrote it as natural log of x to the 1/2. And then for the power rule, bring it down front. And that's 1/2 natural log of x. Any questions on using the rules so far?
Why did you do the half?
That's just one of the rules. That's you can write it as square root of x or x to the 1/2 power, same thing. Cube root of x or x to the 1/3 power, 4th root of x, x to the 1/4 power, and so on. So whatever your radical is, that's how you can rewrite it as an exponent. All right. So let me erase some of this stuff. So we want to expand this expression as much as possible. We have log base a of x squared times square root of y. Because it's multiplication, that means we can, keep forgetting that I have this one, break it up this way and use addition. So it's log base a of x squared plus log base a of the square root of y. Then use your power rule to bring your exponents down front. And that's going to be 2 log base a of x plus 1/2 log base a of y. All right. Next one. Log base 6 of the cube root of x over 36 y to the 4th. So we just have to be careful here. So this is how we can break it up first, using the relationship of your quotient or division. We break it up log base 6 of the cube root of x minus log base 6, 36 y to the 4th. So now we can break up that second term, the term that follows the subtraction, a little further because we have 36 and y. But keep in mind that however we break it up, that minus sign needs to be applied to, this minus sign right here, needs to be applied to whatever follows. And that signifies that that's also in our denominator. So everything in the denominator will have a minus sign in front. So that's how we did this. Log base 6, 36 minus log base 6 of y to the 4th. Next, I rewrite everything with an exponent. So I had already wrote the cube root of x is x to the 1/3, but 36 is 6 squared, and the reason why that matters is because our base is 6, so it's going to help us out. And then y to the 4th was already written as y to the 4th, so bring your exponents down front for log base 6 x to the 1/3 and log base 6 y to the 4th. But then in the middle, log base 6 of 6 to the 2nd power will reduce to just 2. All right. Questions? Any questions? All right, so that exercise, we were breaking logarithms up, expanding it out as much as possible. The next exercise is going to do the reverse. We're going to condense them, and we're going to write them as a single logarithm. So this first one, we have log base 4 of 2 plus log base 4 of 32. So basically, we're going to use the logarithmic properties in reverse. So before, we would use multiplication to break it apart. Now we're going to use that relationship to bring them back together. So if I have log base 2 plus log base 4 of 32, log base 4 of 2 plus log base 4 of 32, I can bring them back together as multiplication. So it'd be log base 4 of 2 times 32. 2 times 32 is 64. 64 is 4 cubed. And that will reduce down to 3. Make sure we're okay. All right. So the next one, 2 log of 4x minus 3 minus x. First thing I do is take that 2 and take it back to being an exponent. So it's log of 4x minus 3 squared minus log x, or log of x. The subtraction, I keep forgetting I have that. The subtraction lets me know I can bring it together as division. So it's log of 4x minus 3 squared over 2. And that's it. Cannot reduce it any further. Questions? Any questions? All right. So C, we're looking at 4 log base A of x minus 2 log base A of 7 minus 1/2 log base A of y. So the first thing we want to do is to take our exponents back to being exponents. So they're sitting in front of the log, take it back to be an exponent. So we have log base A of 4 minus log base A of 7 squared. I said 4. Log base A of x to the 4th, log base A of 7 squared, and then log base A of y to the 1/2 power, or y to the 1/2. All right. So next we notice that we have these 2 minus signs. So that means that both of those pieces will go into the denominator. So I'll go ahead and bring those together. 7 squared is 49. And y to the 1/2 is still just y to the 1/2. But both of those minus signs, I brought those together. Those terms, those laws with the minus signs. And that means they're going to sit in the denominator for us. 49y to the 2nd power, y to the 1/2 will be in the denominator. X to the 4th will be in our numerator. So you can use the 1/2 power, or you can use the square root. Doesn't matter. All right, questions? Any questions? All right, one more thing in this section. That's the change of base property. And really this property is only relevant or useful for those who don't have the option of that little box right there. Some calculators have that as an option. A lot of calculators don't. A lot of calculators only have the common log or the natural log. But if you actually have this as an option, you don't need to actually worry about the change of base property. So notice Whether you use common log or natural log, it doesn't matter. You'll still get the same result. And so I will show you both ways and what happens. So if we wanted to calculate or find log base 5 of 140, if you notice what happens here, whatever's the base goes down bottom. So that 5 is going to go down bottom. And then the other number is in the top, is up top. So that's how we did that, or how we would do it. If you decide to use a common log, you do log 140 over log 5, and they're going to give you 2.14613 on top, 0.6989 on bottom, which will reduce to 3.07. Now, if you use natural log, still going to do the same application, natural log of 140 over natural log of 5. We get two different numbers, but they still give us a 3.07. So just showing you that it doesn't matter which log you use, whether it's common or natural, you still get your 3.07 at the end of your calculation. Still get the same answer at the end of your calculation. All right. Questions? Any questions? Mm-hmm. So that's it for today. That's two sections right there. 4.2 and 4.3. So try to step out, see if you have any questions. And on next class, we'll be looking to get into 4.4. All right. Any questions or concerns before we go out into the weekend? Everybody good? Everybody straight? Okay. Well, you guys have a good one. Be safe. Anybody still copying? Before I cut off, I want to cut it off. You still copying? Everybody good? All right. So have a good one. Be safe. Make sure you get into my math lab, knock this stuff out. And if you have any questions, feel free to email me, and I'll see you on Monday.
Thank you.
Thank you. You have a good one.